So what's the identity of a microservice, right? It's not a user. It doesn't have a first name and a last name. It doesn't have a phone number. It can't do MFA. So there really needs to be a different attention to this use case.
Welcome to the DevSec for Scale podcast, the show that makes security a first-class citizen for growing companies. My name is Jeremy Hest, Head of Developer Relations at Achilles, the secrets management SaaS platform. This interview podcast brings security experts and practitioners together to offer practical and actionable ways for small and growing companies to implement security best practices using shift-left principles without interrupting developer lifecycles. Welcome back, everyone, to the DevSec for Scale podcast. My name is Jeremy Hess, and with me today is Yuval Yogev. He's the chief architect at Sygnia, really cool startup, which we'll talk about in just a little bit. And before we get started, Yuval, thanks for joining. Let's get straight into it. What are the different kinds of authentication and authorization use cases that need to be handled when building a product?
Sure. So first of all, thank you for inviting me. And yeah, so there are actually so many different types of use cases that needs to be handled. But if I would mention like the top three that are most common in growing startups. So the first one is obvious, is users that want to log into your website, your console, whatever that would be. So they want to sign up somehow. They want to enter the username and password. You probably want to enforce some kind of policies like MFAs or single sign-on. So that's the basic one, and that's the one that everyone knows, right? But apart from that, we have like a couple of more use cases. So for example, one of the big ones that are creating challenges for startups is machine-to-machine. So we're going to touch about that in a few minutes, but not every time that the user is creating the action to do something that it needs to be authenticated. So for example, sometimes you have two services that you actually build and they want to talk to each other, but you want to make sure that only your service can talk to the other service in an authenticated way. But for example, MFA doesn't make sense here, right? So and this service doesn't have a first name and a last name like the user has. So it's kind of a different use case. And maybe the last one that we can mention is external APIs. So for example, many different companies like GitHub or Stripe or practically every company today offers some kind of a public API that users can query to do things on the platform. So that is another use case, right? So again, not every time MFA makes sense here. And maybe you want to limit your API. Maybe some API routes are suited for this kind of role, but the other ones don't. And this is something that is exposed to the internet. So again, this is another niche of authentication and authorization that needs to be handled.
Absolutely. Great stuff. So Yuval, now that we got that first question out of the way, can you give us a little bit of background on yourself and tell us a little bit about Sygnia?
Sure. So as I said, my name is Yuval. I'm the chief architect at Sygnia. At Sygnia, we're a cybersecurity company, and we are building an XDR and using that to perform incident response and threat hunting. So basically what that means is that we engage with clients that are either in a very big crisis. So for example, are being hacked, their network has been breached. Sometimes it's ransomware attacks or many different types of attacks that we see on the wild. And sometimes it's clients that want to make sure that the network won't be breached, or maybe do some proactive hunting to search for threats that might be on their network. So, and we're leveraging our XDR that we're building to do all of that. So that practically means that we try to collect any piece of data that is produced by any type of software that the client has. It can be application logs, it can be network logs, it can be different kind of metrics or files. Basically, again, every piece of data that we can find, we're taking all of that and we're trying to make sense all of that data. So that means that we're trying to ask questions that can lead us to potential threats or breaches in the network. So that could mean either searching for anomalies in the network or searching for behaviors that we know that are suspicious. And obviously the MITRE table MITRE attack table is very relevant here, right? So we would search for many different kinds of techniques that are used by attackers today, and we're trying to find that in all of that data. Once we find it, we're trying to contextualize it. So we're trying to make to create a bigger picture for a single event, because a single event doesn't necessarily represent a complicated attack. So what we're trying to do is actually cross-analyze different kind of sources and create, at the end of the day, a timeline for an attack and see that how the attacker got his first credentials, what service did he log into, did he make some kind of lateral movement, did he take any data out of the network? Many different kinds of questions that are very interesting for us and for our clients. Yeah, that's basically it.
Yeah, really great. Yeah, if this was a podcast for data analysts, then we would definitely talk about the amount of data you have to scrub through just to find all that and put all those points together, because that's a whole different topic.
Yeah, that's actually a great point. So basically, we're half a data company and half a cybersecurity company, and we're really trying to bridge that gap and create insights from both of these worlds.
Yeah, absolutely. So let's get a little bit now into the get our hands dirty, talking a bit more about microservices and the security issues that it poses. So obviously we're seeing more and more companies move towards microservices architectures. So what do you see as some of the challenges in regards to authentication and authorization in that realm?
Sure, yeah. Microservices are very popular and many companies adopt that. And mainly for good reasons, right? There are many very good reasons to adopt that, from easier upgrades to making different teams more independent and so on and so on. But however, microservices pose many different challenges. And in the security area, and especially authentication and authorization, it adds a lot more complexity to the system. So, for example, if you take a look at how systems were built traditionally, so maybe you had some kind of a piece of your software that was supposed to be your your authentication and authorization server, which contained all of the user data and knew which users can do what. In microservices world, you have, say, 10 or 20 or 50 or more microservices, and every one of them needs to know all of these type of which user can do what, and is this user authenticated? Is he allowed to do that action? And what happens is, if you have all of these microservices talking to the same authorization server or authentication server, that creates a very a single point of failure, right? If it has even a small hiccup, it affects so many microservices all around your system. So the solution to that is actually making those microservices independent, also in terms of authentication and authorization. So that means, can they handle it on their own? And to do that again creates another type of complexity, because now you have to have some kind of a solution that again is independent. So for example, one of the topics that we can mention here is JWT. So JWT, for anyone who doesn't know, is a format for storing JSON tokens. And we won't go too much into details, but one of the interesting things about JWT is that, first of all, it can be verified independently. So that means that every microservices, assuming he has some kind of a shared key or secret, it really depends how you handle it, can verify that the JWT token is actually valid and came from an authenticated user. So that's one really good property. And the second one is that it can actually hold data. So the JWT doesn't only hold a signature that you need to verify, but it can also hold data like the user details, the role, the type of session that he's engaging with, and other what called claims. And these two properties together make it very valuable. So that's just one example of maybe how to deal with this kind of challenge. But again, zooming out, having all of those independent pieces in your system makes you think about authentication and authorization all the time, because it's not like you have one part of your system where you handle authentication and authorization, and then you move on, and from then everything is, the authentication is given. Now it's really spread around all of the system. And as we said in the beginning, having those microservices creates another challenge, right? So they need to talk to each other, because when in the traditional way where we had a monolith, there wasn't like cross microservices communication, since there was maybe one microservice. So it was as easy as calling a function, right? And here, when you're, for example, talking between microservices, you have many different new things that you need to consider. So first of all, it really depends what communication protocol are you using between those microservices. So if you're using HTTP or gRPC or other protocols, that may impose different type of authentications that you need to implement. The second one, as we said, if you're using an off-the-shelf product, for example, Okta or Auth0 or Frontend or Amazon Cognito or Azure Active Directory, whatever that is, when we're talking about an identity provider, that's like a very important term in that area. So an identity provider is the entity that holds and identifies all of the identities in the network. So what's the identity of a microservice, right? It's not a user. It doesn't have a first name and a last name. It doesn't have a phone number. It can't do MFA. So there really needs to be a different attention to this use case. So again, you don't want to have MFA. You probably want to have some kind of a different token that they can establish together. And again, in an independent way, without being dependent on the auth server or whatever that will be. You maybe want to have an option to replace and rotate those tokens. So again, it's a very different type of world than the user authentication. And again, maybe just completing the cycle from the first question, we have another use case which is the external API. So suddenly you have maybe an API, a microservice on its own, maybe, that needs to handle internet requests from users that are not necessarily users in your system, but have maybe an API key. So that means that suddenly you need to handle those creating API keys, revoking them, and have every API key not only validated, but you need to somehow store the logic of, okay, that API key can only access these types of, so for example, this is only a read-only API key. It can't actually change or write things into the system, as opposed to the admin API key. So as you see, the complexity of authentication and authorization is big on its own, and then splitting your system into different microservices only fragments this whole thing and makes it even more complicated. And I think this is one of the reasons also that companies like Okta and Auth0 and all of these are there and are actually very thriving, since it's complicated for developers, but it's also very hard to get right. So even if you have the resources into to building it and create some kind of authorization mechanism, it's very, very hard to get right if you think about all of these different types of niches and use cases.
Yeah, absolutely. Complexity. So we talked earlier about the migration with Sygnia that you're making towards multi-tenancy architecture. And before we talk a little bit about sort of the details of security around that, can you just give us a little bit of a background of what the reason smaller companies usually start in that single tenancy architecture?
Yeah, so we see a lot of companies starting with multi-tenancy, and we see a lot of companies starting with single tenancy, and usually that comes with like some kind of a combination of historic reasons of what was easy at that time, plus some constraints that the company had. So, for example, if you think about single tenancy, that could be looked at something very maybe old and not efficient, and that's half true, right? But it does create a lot of advantages, especially for fast-growing startups. So, if we can think about a few of them, right? So, first of all, we don't have the notoriously famous noisy neighbor problem, right? So noisy neighbor means that if we have one tenant that is very large and has maybe a very high throughput of data coming into, and another one which is very low, then in multi-tenancy, you have both of them. If you're not safeguarding it the right way, they interfere with each other, right? In a single tenant way, everyone has its own infrastructure, its own application, its own instances, and you actually, it might be harder to manage since you have a few instances to manage, but each one of them, again, is independent and is not affected by anything around it. Same thing for if you think about deploying, upgrading versions, things like that. It's harder to deploy and upgrade versions to 20 tenants if you do it one by one. However, if you only have one to upgrade, then you are limited in what you can do, right? So if you deploy and you have some kind of bug or a downtime, which happens a lot for for new startups that want to move fast, then you have downtime for all of your users instead of maybe for one user. Maybe you wanna, in a single tenant way, you can roll back one tenant that has maybe a specific problem and let the other one proceed. So it's really a trade-off between flexibility and ease of operations in terms of putting it all in the same place.
And that drives us to the next question, right? So obviously, getting to multi-tenancy, it makes a lot of sense, especially from a financial standpoint. But in terms of the complexity of dealing with security, what are sort of those security issues that you're seeing, because of, let's say, through the transition of, becoming multi-tenant, and then also dealing with just the complexity as a multi-tenancy application?
Yeah, so as you said, there are many very good reasons to move to multi-tenancy. So financial is maybe the top one. Having the same, sharing the same infra makes you much more efficient in the resources that you spend. Also, again, as I said, in terms of managing only one thing, it's easier. But actually, I want to stress out a point here is that multi-tenancy doesn't have one meaning, right? So it's a very big word. And sometimes maybe some people think that, okay, multi-tenancy means you have one server, one instance of your application, and that's it. That's for everyone. And that's not the case all the time. So multi-tenancy can mean different things at different levels of your application. So just one example, if we take databases, for example, multi-tenancy can mean, okay, we have one table and we're putting all of the data of all of the tenants together, and we have, the tenant ID column. And when we query a data of a tenant, we just add the, the where tenant ID equals X. But that's not the only solution, right? We can have different tables for different tenants. We can have different schemas for different tenants. We can also have different databases for different tenants. And, saying that one is multi-tenancy or one is not, it's kind of a gray area, right? So multi-tenancy can mean a lot of things. But anyway, when you're getting into putting different tenants closer together, okay, maybe that's the more accurate way of saying it, security challenges start to arise, right? So let's take the database example again. So we took all of the different databases, we merged them into one, so now we're super efficient, but now all of the tenants' data is in the same table. That's great. That creates a huge security concern, right? What happens if someone gets access to your database? Can he view all of the tenants' data? It has only one password, right? Are you limiting? Are you performing what's called row-level security, meaning different types of users can only access different types of rows? How are you making sure that for example, your web application? How do you make sure that not any developer forgot to add that where clause, right? So if select star from whatever, and he didn't add the where tenant ID equals something. What happens? Do you have some kind of way to make sure that a human mistake wouldn't create such data leakage or something like that? So that's like a huge security concern, right? When talking about authentication, we can talk about the same thing, right? You don't necessarily want to have, for example, the same token or the same secret to create tokens for different tenants. I mean, if a user is authenticated for his own company, right? If I'm logged into one of our SaaS that we're using with my own user, can I somehow take that token and maybe try to fraud myself as someone else and log into a different organization? Because in the backend, that is only one instance of the app, and it stores in one database, and it only has one secret. So it's a very hard trade-off, putting it all together in terms of resources and financial resources and management and upgrades and all of that, but still having those the right separation at the right places. So whether it in the table level or the schema level or the app level or there are many different types of solutions to solve it. But the point is that when you're moving to multi-tenancy, you always have to have that in mind. And when you're dealing with single tenancy, that's a little bit easier, right? It's not the easiest thing, but it's a little bit easier because everything is separated in the highest level, right? It's not the same server, it's not the same database. And
you do multi-tenancy though from a Kubernetes level. Is that right?
Yeah. So we're heavy users of Kubernetes. Because of many different reasons, for auto scaling and for easier hardware abstraction and many good things that Kubernetes gives us. If you look at Kubernetes in terms of multi-tenancy, that starts to be very interesting because again, Kubernetes, the basic idea is again hardware abstraction and container orchestration. So that means that, for example, if you're running all of your software on the same Kubernetes cluster, that means that your multi-tenant, your multi-tenancy is in the infra level because they share the same servers, right? It doesn't necessarily mean it's on the application level. It doesn't mean that it's the same container actually that is serving all of the clients. It can mean that, but not necessarily. And when you're putting everything in the same infra, you have to have, again, some kind of separation. So Kubernetes gives you a lot of flexibility in terms of applying that separation. But again, you have to have that in mind and apply it correctly. And that's, again, something that is a bit hard to get right. So for example, one thing that we can mention is namespaces, right? That's a very popular building block in Kubernetes that is giving you logical separation. It's a very important building block. However, it's not a security mechanism on its own. Actually, it's not a security mechanism at all. It's just a logic separation between resources on the cluster. However, it gives you the base level, the right terms to talk about when you start applying security mechanisms. So what security mechanisms, for example, are we talking about? So the first one and the most basic one is network policies, right? So you want to avoid in all costs the opportunity that a namespace of tenant A would somehow be able to connect or communicate to a namespace in tenant B. And again, behind the scenes, those can share the same server or being in two different servers, but in the same network. But you have to have a layer of network policy that will that won't allow this type of communication. So again, namespaces can be a very powerful tool here, but they must come with additional layers of security on top of them.
Absolutely. Great stuff. So one of the things that I ask, some of my guests, which have, a product that is meant to be used, also in-house sometimes. So we call that dog fooding, of course. Do you guys eat your own dog food at Sygnia? Do you use your own product?
Yeah, that's a great question. So first of all, the answer is yes, obviously. So again, as a security company in general, and specifically a security company that deals with sometimes very sensitive situation, we are extremely serious about two things. We're serious about our customer security and data, and we're serious about our security and data. And these actually, they overlap, because obviously Sygnia sees so many clients, and we have to have our, the most, the best security that we can have, both on our network, on our data resources, and on everything. That's by the way, one of the reasons to start with single tenant architecture, because your tenants are separated in the most extreme way. So yeah, we are definitely using our own XDR, which is deployed at Sygnia's network. We actually treat it as one of our clients. So we are one of our clients in every term, right? In terms of resources and financial and support and security and everything. And we are constantly using the system. We're doing proactive hunting. We're looking for things in our own network to make sure that we didn't miss anything. So we use it heavily. And that's actually a very nice thing, right? Because you get to use your own product all the time and think about improvements or new areas that we can create and really improve the product, because again, you're using it on your own.
And you're finding the same issues that users might be finding, and you're able to patch them quickly and move forward. So that's always a great reason to be using your own product. So the last question that I'll ask, and thanks Yuval for your time. Can you give us one or two tips that you have for developers in, let's say, smaller organizations that can help them implement kind of a security best practice into their daily routines that won't interrupt, their general workflows?
Sure. I think that today, if you're talking about best practices, it's very, everyone knows that you should have MFA. Everyone knows that you should have a way to revoke tokens. These things are kind of, but I think that the most interesting part is how do you do that correctly? And as you said, without interrupting, the whole, I wouldn't say without interrupting, I would say keep your focus on your business, right? Build the thing that you want to build and not worry about security all of the time, because you won't have time to do anything else. So my general tip here is buy and don't build. And this is coming from, and this tip is not always true, right? Not in every case that is true, but especially for growing startups that have limited resources, limited time to deal with that. And again, it's a complicated subject, right? We talked about the different use cases and microservices and Kubernetes, and it's so many verticals to consider here. It's very difficult to get it right. And my tip again here is buy and don't build. And there are so many great products out there to use. And yeah, you're better off using something that is, checked and validated and have the right compliance, and just, move your worries from you to the company that actually specializes in it. And you focus your time on building the thing that you're specialized in. So that's my tip.
Wonderful. Love it. So Yuval, thank you so much for your time. This was a really great discussion. I think we got a lot of fantastic information. So really appreciate it. And I hope that we can follow up on a future podcast or a meetup. And looking forward to seeing you again.
Thank you so much, Jeremy. It was a pleasure.
You got it. Good luck with Sygnia and have a great day.
Bye-bye.
Bye-bye.